Um, Good afternoon, everyone. I hope I'm audible to everybody. So we are Securenet Innovators, and we are working on next. We are working on problem statement number 3, which is to design a benchmarking tool for intrusion detection and prevention system. So we are referring to RFC number 9411, and what we are delivering is a tool that benchmarks the IDS and IPS, and it also helps us to visualize the performance. The visualization of the performance is done with the help of graphs. I will demonstrate it later. Next. So what we got done, we have made an attack vector which is extremely customizable. It can give any type of traffic input, traffic output, and it has real-time monitoring of the server, all the traffic that is coming. I will also demonstrate another thing, and then we have the links. Next. So the tech stack we have used is Golang for the benchmarking tool. We have used Golang because it is faster and it also had some pre-installed libraries, so it was easier to get the work done. We have used Python and Flask for making our test server, and we have used the tkinter library in Python for the graphical user interface, so that the UI UX is better. And we have used normal HTML and CSS and JavaScript for the server development. So we have 3 basic components. First is the user. The user has our benchmarking tool. Okay, like the benchmarking tool is with the user, and the user requests, for example, he searches on Google or anything, to the server. The server has an IDS or IPS, and now suppose an attacker will attack at the server, and the IDS and IPS will work, and what the benchmarking tool will do is monitor this server and the IDS and the traffic, and then give us and perform some ML analysis. This is in our future prospect, and then it will give us a benchmarking result. For now, our benchmarking result does not include any ML. Next. So I've shared some screenshots. So this is our dashboard. Our dashboard shows a lot of graphs. I will come to it. And if we are lucky, we also get a pop-up saying that high traffic detected. And this is how our benchmarking result comes out. So these are the parameters. I will show it next. And this is the GUI of our attack vector, and this is the GUI of our IDS and IPS. This IDS and IPS we have made on our own. It is made from scratch, and it just says high traffic alert yes, and we can also flood the traffic. So this is the IPS part, and this is the IDS part. Next. So we will be sharing a demo video.
We have our class server written down.
We are switching on our class server.
So
we started.
You can see that it has been hosted in this particular IP. We will go to the.
This is the class server. You can see there are many graphs.
You can see that
throughput.
The throughput.
All this is real time.
Server, the latency.
It changes with time.
Usage and the memory usage is being tracked along with the logs. You can also download the logs from here. And as a control, we will be checking our
So meanwhile, what our demonstration video shows is that we have first user control. So first we will test our benchmarking tool on a server that is not attacked, and then we will use it on a server that we will attack using our attack vector. I'll just demonstrate. So we are showing all the real-time graphs. So this is for our control experiment. So this is our benchmarking tool. It is the GUI version. It is extremely simple to use. We just need to input the URL. Just inputting the URL is required, nothing else. It will configure on its own. This will configure it. The benchmarking takes like 5 to 10 seconds. It's very fast because of Golang. is the output, this is the benchmarking result we get. So you can see it is 100%. So this is for the control, there is no attack on this system. So this shows 100%. And then we will attack a server and see. So we will now simulate a DOS attack. The DOS attack we will simulate using our own vector. And for the vector, so you can see. So you can see when we perform the DOS attack, it is going up. Okay. Can you please skip to 410? So we are inputting the parameters for the DOS attack. So we'll skip it because this is the highest form of DOS attack we can go through. We have used the maximum range, and now we will see how it affects our real-time server. So you can see that the DOS is making like this, it will again go. This is the DOS attack, and it is visualizing. You will also see the CPU and the memory usage. So the latency has gone down, the CPU usage has gone up, and also the memory usage has gone up. So all this we can visualize extremely well. And then we will benchmark it again. So this is after the DOS attack. So you will see that like before it was 100%, but now once this is done, you will see the result. It has come to like 85%. It is not visible right now. It has come down to 85% because of the DOS attack. So we have successfully tested the thing, and it shows us the results as well. Now you can pause it and you can go to the next slide. So what we are planning is go to the next slide. So what we learned is that like the issues with the RFC is that in today's world ML is extremely important, but the RFC does not implement ML at all, and for that some new implementation we could suggest that we can use keyless encryption. That is what the RFC tells us that why HTTP 3 is better than HTTP 2. Then for the ML part, so the tool that we have created for the attack vector, what we will do is that we will use that tool and we will randomize the values of every parameter and generate like we can run it like 10,000 or 20,000 times, and then a data set will be created. So prior to this project, the data set was not available on the internet. So Mr. Devraj, he was our mentor, so he suggested us this method. So we will get a data set and then we will use the inversion model, which is a anomalous detection model. So what it does is it has a specific range of a parameter, and if that range is like an anomalous number is we get an anomalous number out of that range, it flags it, and then this kind of unsupervised learning is like we can flag like suppose 4 or 5 parameters are getting flagged, so we can grade and benchmark the result according to that. So that will be our future implementation. Go to the next slide. So this is what our future plan is, and as you saw the dashboard, it is not interactive at this point. So what we will do is we can make the like at every point you can go and navigate. So we will improve the UI and the UX over there, and we will create a data set as I mentioned, and also the AI model we will use implementing that data set. And for the wrap up, we are team Securenet Innovators, and the team consists of Nabhonil, myself Sampurna, and our mentor Mr. Karmakar. We are from Heritage Institute of Technology, and we are in our second year of computer science. And these are our contacts. And so this is the end of my presentation. You could go to the next slide. So this is a very special slide. this is to thank all the organizers to give us such a great opportunity to showcase, to come participate and participate in a very not a very like hackathons are not really on security or networking. So this is a very specific hackathon, and it is a one of a kind hackathon. So, and also for the guidance, support and mentorship. And as I mentioned, it was a one of a kind hackathon. In most of the hackathons, the judges just judge, but over here, all the judges come and they mentored us. They told us how to implement. I would especially mention Ornov sir, who told us how to do the ML, and Devraj sir. And also for the hospitality and the financial aid, I fell sick on the first day, and sir and Mrignani ma'am, and also Onji ma'am, they helped me a lot. They took me to the hospital. So thank you for this opportunity, and I'm very grateful. And our team is very grateful to be here. Thank you.
Any questions, sir, for us?
Exactly what are we trying to do?
Yes, sir. The thing that we were probably
It's the same RFC as previous.
Yes.
Yeah, in RFC.
So was there task to implement the RFC or tool using the RFC?
Sir, our topic was like intrusion, like to benchmark intrusion detection and intrusion prevention systems.
So that means you will take an existing intrusion
yes, sir.
ideas or
Absolutely.
IPS,
Yes.
and then you will try to benchmark it.
Yes.
Yes.
The performance may
So
differ
which is the
from
intrusion
device
detection
to-
system that you actually chose to benchmark?
So
Sir,
we made us
we made our own first sample IDS IPS from scratch in Python. So we could test. It can be any it can be any IDS like Suricata, and there
so
are
in
many
the
you can
RFC,
try
it was mentioned that the ideas just has to be like the test bed that was given in the RFC was that it should just detect high traffic. So that is exactly what we did. We stuck to the test bed that was provided in the RFC. So that is the reason we made the our own ideas. Like before we thought of using Suricata, but that was then we thought
So
this was
you didn't describe the method by which you built your ideas.
built our ideas.
the methodology that we used, we took it from IDS. So what happens in Suricata, if a high traffic or a high traffic is detected, the traffic is split into multiple threads to manage that incoming high traffic. So we did that in our program also, and the high traffic detection that was there. We haven't implemented like many features that Suricata provides, but we
So
just
for high traffic,
yes.
you built your own system to detect whether there is high traffic or not.
Yes.
Yes.
Okay, that is the
Ideas.
scope of ideas that you are concerned with. Now, what else did you do? You benchmarked.
Yes, sir. So our the problem statement that was given to us
You
was
benchmarked it, or you actually see? I think somewhere you're confusing the term benchmarking with testing.
no, sir. So our goal was like the problem statement that was given to us was not to make ideas. We just made it so that it could
Yeah,
be
fair
easy.
enough. So that is your okay. Now on that,
So
what you're trying to do? You're trying to test its
Benchmark.
performance.
yes, sir. Yes, sir. So
So
the
see, somewhere you're confusing the term benchmarking with the term performance measurement. Does that RSC anywhere say benchmarking?
The RFC doesn't say benchmarking, but it says performance
No,
testing.
what I'm saying is I suspect,
Yes.
because also during that failure of the laptop, what you probably meant is if you had tested the system, this would not have happened.
not tested. We would have benchmarked that.
What in your view is the difference between testing and benchmarking?
Benchmarking is like comparing performances between many IDS and IPS. And testing is like we test it on one IDS
So
or IPS.
you didn't mean that, no? You didn't mean compare that laptop with 60, 70 other laptops to see whether this was happening.
So testing is like suppose if I would have plugged out on this laptop, that would be testing. But if I would have taken like 100 or 1000 laptops, a set of laptops, and then seeing that okay, is it working or is it not working? So for example, if in 1000
So that would have been benchmarking.
yes.
But when you refer to the failure of the laptop here, were you meaning that we should have tested it, or were you meaning we should have benchmarked it?
Benchmark, like the company should have benchmarked it and we should have tested it.
Be very clear when you use terminology.
Okay, sorry.
और अगर गलती कर दिया तो बोल दो गलती की है ना, नहीं तो पकड़े तो जाओगे.
So we will try to be careful.
So now, now the RFC tells you how to measure the performance of this idea, right? So you made up an idea. Now, what is this telling you? Is that this is what is your concept of performance of this idea? When you say I am trying to assess the performance, what does that mean? Performance against its ideal,
So actually,
or performance in terms of how many packets are being lost?
yes, can you show the result? So I'll show demonstrate.
So if you are saying that 85% of the packets are being lost,
No, so that was the error percentage.
okay, so what is the meaning of performance of the idea?
So performance of the ideas is like how much it is being able to block, or like can I show
As
you
compared to what? As compared to some conceptual capability?
So we have made this tool so we can simply benchmark different IDS and IPS across the internet.
So like if
So
the
you get some performance number out of one,
Yes.
then some performance number out of the second,
Second.
some performance number out of the third, and you compare them.
Yes.
But this actual performance number, what is it? You have no clue.
no, so we are checking that how much traffic is affecting the
What?
the server. So in the first case in the control we saw that it could not affect the server. Because there was nothing. We were not
Did
attacking.
not affect the server mean what? That means you lost that many packets. That means the server CPU utilization went down.
So we have taken not only one, we have taken parameters sir, can I show you the TXT
Then
file?
what I am saying is, somehow you are making a conclusion about the IDS where you have lot of other parameters like the hardware capability, the NIC card, all of these things which may be causing the problem and not the IDS itself.
Yes, sir, there are also many factors that we haven't taken into consideration as of now. Sir.
So then this is the question I am asking you, what performance did you measure?
Only the packet received and the sent performance that we have
It's a
measured.
traffic.
Traffic
And that-
measurement.
You concluded is a good way to check the performance of an IDS. But your number could change if I just deployed it in a machine with greater resources.
Yes, sir. The number can change.
So that doesn't tell you how efficient that IDS is.
Yes, sir. IDS efficiency can change from device to device.
Okay, thank you.
Thank you, sir.